sort of, yeah. So let's have a look at SUVAT. Hopefully we've got some SUVAT stuff over here. Here we go. So SUVAT equations or kinematics. It's called SUVAT because SUVAT spells the different quantities that we're looking at: displacement, initial velocity, final velocity, acceleration, and time elapsed. And we're talking about an object that is accelerating at a constant rate from one speed, one velocity to another velocity. So you could draw a graph and it would look like this. Whatever the initial velocity is, it's going to accelerate up to a final velocity, and it's going to take a certain time to do it. Now, the difference is this graph could start at 0, it could even start at a negative, and also it could have a negative gradient. But it would always be a straight line, and so what we did is we looked at how we can derive these equations, which I'm not going to do now, but in fact there's a video up there that shows how I derived those equations. But these are the different equations here. So we then, and you can use these equations, decide which one to use to solve various SUVAT equations, SUVAT questions. So for example, Bob ran 30 meters starting at an initial speed of 2 and finishing at 10 meters. I'm asking you to calculate the time and the acceleration. So I've given you the displacement, I've given you the initial velocity u, and I've given you the final velocity t. So if I want to know what is the time, what equation do I use? Well, I use the equation that has the displacement, the initial velocity, and the final velocity, and time, but not acceleration. So I would use this equation. I may have to rearrange it, but that's the equation I use because for the first question, the only thing that I don't need to know and I don't need to find out and I'm not given is acceleration. So it's the equation without acceleration is the one that I want. For the second one, I do want acceleration, and let's say that I didn't need to know time, then I would need to use this equation down here. Again, I'd have to rearrange it, but this one doesn't have time in it, so that's how I know to use that one. So the whole reason for having 5 different SUVAT equations is because there's 5 different variables, and we decide which one to use based on which variable, which quantity do we not need to know anything about. So that was a whole lesson on SUVAT there, which I won't go too much into at this stage, but I want to briefly bring in the work on projectile motion. So with projectile motion, the first thing to realize is that when something is moving let's say it's moving from this ball is moving all the way over here. The question I first asked is, let's imagine we had a bullet or a ball being moving that way. It's going to gradually come to the ground, and this one is being dropped at the same time. They would both hit the ground at exactly the same time, and that is because horizontal motion and vertical motion are entirely independent of each other. They do not affect each other, and so you can imagine them as 2 different. So if one ball going like that, you could imagine it as 2 different balls moving, one moving horizontally and one moving vertically. And then the only thing you would know is that they would both hit the ground at the same time. And then you would use all the information, you would combine the information in order to solve whatever problem you're trying to solve. So if we look at this, for example, how long will it take for each ball to hit the ground? How far will it travel? Well, so we first of all think, what do we know from something that's in this situation? It's starting from 0, starting from rest. So the initial velocity is 0. We don't know what the final velocity is, but we don't need to know it. So we're looking for an equation without v in it. The acceleration would be equal to g, the gravitational field strength. The time is what we need to know. So let's circle that. And then we've got S. We should have written out SUVAT, really. So it makes it a lot easier to remember what we need to know by just literally writing SUVAT. That's why we call it SUVAT equations. But so the S is 5 meters. So So basically, we need to know an equation that doesn't have v in it. So let's see if we can pause the video and work it out. There you go. So awesome. So it's s equals ut plus half at squared. So we know that u is equal to 0. So 5 meters is equal to half times 9.81 times t squared. You would rearrange that, and then you would find, with a bit more maths, you'd see that it's just over 1 second. You then, to work out how far is it going to travel, you're then going to sub that in to, so this is how far will the ball travel. This means this one to the right. I've not written the question very well, but the one to the right, how far is it going to travel? And it's, you would say, well, it's going to be the same amount of time to, of the journey. So we're going to use that 1.0096 seconds. And we would just sub it all in, and we find out it's 25.24 meters. So the key to projectile motion questions is to work out what you can work out by the vertical and the horizontal story. So you kind of imagine there's two different stories going on there. There's a horizontal side of things, there's a vertical side of things. But whatever happens in each case, they both take the same amount of time. So you do what you can to eventually get to time, and then you realize the time's going to be the same for both of them. So that's the key to get from horizontal to vertical, or from vertical to horizontal, whatever it is you're trying to do. So that's what I did there, is I looked at how long it took for the ball to fall, and then that gave me the time of the entire journey. And then I said, well, because horizontally it's traveling 25 meters per second, then there's no, and we're assuming no air resistance in projectile motion. So horizontally, the speed is always 25 meters per second, and so we would just multiply 25 by the original time, and that gives us the total distance of just over 25 meters. Okay.